You know that feeling, right? You're using an app, everything's going smoothly, and then bam, it just crashes. But then you've got other software that just works, like perfectly, every single time. What's the difference? Well, a lot of the time, it all comes down to testing. But here's the real question. How do developers actually know if their testing is any good? And yeah, that's the core challenge, isn't it? It's all about moving away from that kind of gut feeling of, yeah, I'm pretty sure it works, to having cold, hard proof. To get that proof, you need a way to measure how much of your code is actually being put through its paces by your tests. But, and this is a big but we're going to come back to, just because a piece of code ran, that doesn't mean it's correct. Okay, so here's our game plan for this explainer. We're going to start with this big quest for quality, then we'll dive right into the nitty-gritty of something called statement coverage. We'll get hands-on with it, look at its strengths and weaknesses, and then kind of zoom back out to see how it fits into the big picture. All right, let's kick things off. To really figure out how good our testing is, we can't just look at the software from the outside. We have to pop the hood and look at the engine, the code itself. This approach is called white box testing, and our main tool, our primary gauge on the dashboard for this kind of work, is something called code coverage. So what is code coverage exactly? Well, the easiest way to think about it is like a report card for your test suite. It gives you a simple percentage that answers the question, how much of my code did my tests actually run? And this isn't just a number for the sake of it. It's absolutely crucial. It helps you spot bugs early, it tells you if your tests are even doing anything useful, and it's a huge step toward building really high-quality software. Now, code coverage is kind of a big umbrella term. There are a bunch of different ways to measure it. So today, we're going to zoom in on the most fundamental one, the real ground floor, the place where pretty much everyone starts. And that's called statement coverage. Okay, so statement coverage, you might also hear it called block coverage. It has one simple, straightforward goal. Make sure that every single executable line of code gets run at least once during testing. That's it. No line left behind. Yeah, every single line, run it once. That's really the mantra here. The best analogy? Just think of your code as a giant to-do list. Statement coverage is just you going down that list with a pen and making sure every single item has a check mark next to it. It's that first basic pass to make sure nothing was completely forgotten. All right, theory is one thing, but this stuff makes way more sense when you see it in action. So let's get our hands dirty. We're going to take a simple piece of code and walk through exactly how you'd calculate its statement coverage, step by step. Okay, check out this function, calculate result. It's super simple. It just takes two numbers, A and B, and adds them together. Then it hits a fork in the road, an if statement. If the sum is greater than 0, it does one thing. If not, it does something else. So we have 4 executable statements here, the sum, the if check, and the 2 possible return lines. So how do we actually measure the coverage for this? Well, it's a pretty simple process. First, we identify all the statements we need to hit, which we just did. Then we design some test cases. We'll run those tests, see what lines get executed, and then calculate the percentage. If we're not at 100%, we just figure out what we missed and write another test to cover it. Okay, let's run our first test. We'll say A is 1 and B is 2. The sum, of course, is 3, which is positive. So the code runs statement 1, then statement 2, and since the condition is true, it goes inside the if block and runs statement 3. And that's it. The function is done. But look what happened. We totally skipped statement 4. The entire else block was just ignored. So let's do the math. We have 4 executable statements in total, and we just ran 3 of them. 3 divided by 4, that gives us 75% statement coverage. Hey, not bad for one test. But we've got a very obvious gap. We need to write another test that specifically targets that last line. So for our second test case, let's be strategic. We need to hit that else block. So let's use negative numbers, like A equals -1 and B equals -2. Now the sum is -3. So this time, when the code gets to that if check, the condition is false. It skips statement pre and jumps right down to the else block, executing statement 4, the very one we missed before. And there you have it. If you combine the results of both tests, you can see we've now hit every single one of those 4 statements. We have achieved 100% statement coverage. Mission accomplished. So we're done, right? The code must be perfect now. Well, not so fast.
You see, getting to 100% statement coverage is a great milestone. It really is. But you have to think of it as just one piece of a much, much bigger puzzle. It's a really important piece, for sure, but it doesn't show you the whole picture.
Let me give you an analogy. Statement coverage is like taking a tour of a house and making sure you step into every single room. That's good. But there are other tougher kinds of coverage. Decision, or branch coverage, is like making sure you've gone through every single doorway in both directions. Even better. And then you have things like condition coverage, which is like going into every room and testing every single light switch to make sure it turns on and off. Each of these levels gives you a deeper, more rigorous understanding of your code.
And that brings us to a really, really important point. Statement coverage is an incredibly useful tool, but it is not a silver bullet. You have to understand its strengths, but you also have to be really aware of its blind spots. Knowing what it can do and what it can't is everything. So here's the trade-off, right? On the plus side, it's awesome for finding chunks of code that your tests are completely ignoring. It's simple, it's easy to understand. But the limitations are huge. It can completely miss bugs in your logic. It doesn't care about boundary cases, like what happens if the sum is exactly 0. So this is the thing to burn into your memory. Statement coverage proves a line was executed. It does not prove that the line is correct.
So let's wrap this all up. What's the big picture here? It's really all about understanding where statement coverage fits into the whole process of building high-quality, reliable software. Here's the key takeaway. Statement coverage is your foundational checklist. It's your first line of defense. Its job is to make sure no part of your code is completely invisible to your tests. It's fantastic for finding those big, obvious gaps, but it's just that, a first step. If you want to be truly confident that your code is not just run, but that it's right, you have to combine it with other, more powerful metrics like decision coverage. And that leaves us with one last big question to chew on. Is code that's 100% covered the same as code that's 100% correct? And after everything we talked about, I think you know the answer is a resounding no. Coverage proves execution. It doesn't prove correctness. And understanding that fundamental difference, that's what really separates good testing from great testing.